Hello, so this question is bus routes. So yeah, you can read over it. So you want to return the list number of buses you must take to travel from source to target. All right, so uh, this question is not trivial. So I'm going to explain what happened. All right, so for this for this one, you have a bus like travel from 1 to 2, 2 to 7, 7 back to 1, and then 1 to 2, and then keep going. And this one is 3 to 6, 6 to 7, 7 back to 3, and then keep going. So you want to think about like how many buses you need to take from the first stop to the target, which is the last stop. All right, so let's just draw a diagram first. So 1 to 2, 2 to 7, and 7 will back to 1. This is how the bus drive, right? And then you have what? 3 to 6, 6 to 7, and 7 will back to 3. This is how the second bus drive. So you started from here, and then you want to know how will you be able to get it from here. All right, so this is pretty much the idea. So you comes here, and then you comes here, and then you comes here, and then now you know, oh, I'm waiting the second bus, so you comes here, and then you comes here, and then now, oh, you verify your stop, which is the target, then you want to what, return right away. But how many bus you take? So this is the second bus, right? So 7 is a duplicate, right? 7 is a duplicate, so let me use another color. 7 is the common stop. So 1, 2. All right. So that's pretty straightforward. But what happened if you have example 2? They just erase. I mean, it's easier to visualize, but let's see. 7 to 12, and then 12 back to 7. And then 4, 5, 15, and then back to 4. 6 will go by itself. And then 15 to 19, 15 to 19, and then 19 will back to 15, and then 9, 12, 13, and me 9, 12, and then 13, and then 13 back to 9. So your first source is what? 15, right here. You want to know, are you able to get to 12, right? You want to know, are you able to get to 12? 12. Like, this is no way. You are actually in two different, what's that called? Two different cycle, right? You are in this bus, you are traveling in this cycle. In this bus, you are traveling in this cycle. So you return -1. They are not going to happen when they can drive in from here to here. So yeah, so that's pretty much the idea, right? So what you should do, so for example, what you should do is 1 is going to be 1 stop, 2 is going to be 2 stop, and then so on, right? So 1, 2, 7, and then you have 3, 6. Because every single stop can be a common stop, right? So you want to know, oh, let me see, hold on. So it's going to be a list for, 1 you connect to what? 2, right? No joke. 2 you connect to 7. 7 you connect to 1, but also you connect to 6. Sorry. Also you connect to what? 3, right? And 3 you connect to what? 3 you connect to 7, right? 6 you connect to what? I believe is, wait, 3 you connect to 6. This, my bad. Something like this. 6 you connect to 7. Yeah. So this is like 1 to 2, 2 to 7, 7 you will to 1, or 7 you will to 3, right? And then 3 you to 6, 6 you to 7. So this is the every single stop that you can go through, right? So once this happens, and then basically you just keep doing this, and then you want to, first of all, this is the final array. Like you don't have the initially. You're going to traverse when you read it from the array to the array routes. So you have a source, and then every single source. So you're going to have a source, which is going to be you are going to put into Q. Q is this. Q is 1, right? So you traverse 1, and then you read from the routes, and then you know 2. 2 is your next stop. So you go to 2. And 2, you know, 7 is going to be the next stop. So you go to 7. And then 7, you traverse, and then you find out, I have 1, I also have 3. So you go to 1 here, you go to 3 here. But the problem is you don't want to revisit every single time, right? This is going to be duplicate. So you're going to mark as visit or not visit. And then if this is visit, we ignore, which is continue, right? And then 3 you will connect to 6, right? And then is 6 your final stop? Yeah, target, right? So you return how many bus, which is what? This is going to be 1 bus. This is going to be a second bus. Second bus. All right, now just matter of the implementation, right? So let's do this. So if the if the source is equal to target, then you don't need to do anything. So this is the base case. All right, hash map integer, and I'm going to store as a list of integer. And the map, new hash map. And then I want to declare the array for every single stop, right? For in bus, and then and I'm going to just say method compute if absent, and I'm going to say bus x new release. All right, and then I'm also adding the current one, the current index, which is going to be the bus 1, bus 2, right? And then q integer, right? Q equal to new linked list hash set for what? I'm going to say visit path, and also visit stop. For example, this path has been visited, like you don't want to revisit again. Or for this one, if the stop is visited already, you don't want to revisit. Alright, so the first thing is I want to know how many bus I need to take. So it's going to be integer, right? And I'm say q.offer the current source, right? And also if this is going to be the starting position, I know this is the what I already visit, right? I'm going to say visit stop the app the source. So one thing I was saying this one, I knew which bus I'm going to take, right? This is index. So yes, let's see. So while the queue is empty, so I need to traverse how many items in the queue, right? So queue.size. And then this is going to be represent 1 bus, that path you can go through. So every single time, this is represent 1 bus. And I need to traverse how many possibility that I can go, right? So at least that really straightforward BFS. All right, now we're going to have what? The current stop is going to be poll. So I'm polling my first stop, which is going to be 1, right? 1 here, and then I want to check. So I have 1 here. I want to check what is the the path for the current stop, right? So for in path, and then meta get or default, and then current stop. Or if the current stop is not in the map, then you will just return array list. Then you don't have error. So you see what I'm saying? What I'm trying to do? Current stop equal to 1. It's definitely going to be true for the source, right? So I have this. I already have initialize the path. So this is represent 0, 1, 2, 3 based on the path, right? And then once I have it, I'm going to mark. So if the current visit path visit path has been visited, which is going to be path. I don't want to traverse again, right? Also, I'm just add a path, and then once I add it, I need to traverse how many, the current path, right? If this is the current path, I want to traverse how many stop, right? Stop. So for in next stop, and I'm going to say based on the path, right? And I'm traversing based on the what? Based on the stop, right? So if stop dot contains next stop, I don't want to visit. Oh, that's why I'm doing a send. Just add the next stop. Alright, once I add it, and then if the next stop is equal to the target, then we want to return the result, right? Like your next stop. So this is the next stop, right? It's not in the next path, right? So if this is true, you already increment your, the bus count, right? You can just return. All right. Now, then if this not equal, then this is another possibility that you can traverse from one to the other, right? So you're gonna say q dot next stop, right? And at the end, whatever whatever you traverse, and then you pop out the while loop, and then it's not going to be true, then you return -1, right? So this is ideal, right? This is ideal. We want to make sure this is going to be returned right here, and then if not, you return here. So I'm not sure. Oh, all right. One-time perfection. Okay, so think about this, and then just basically draw on the paper, and then you'll be able to understand what's going on. The idea is that you don't want to revisit every single stop, right? So this, I believe, is what 1 to 2, 2 to 7, and then 3 to 6, 6 to 7, 7 to 3. So for example, you are at least oh, come on. You are at least stop, and then you already visit this one. You already traverse this path. You don't want to traverse again, right? Oh, I forgot one path, which is this, right? So you don't want to traverse. So this is what you want to ignore. And then if you have this path that you traverse, then you don't want to visit again, right? So this is a mark, a time saving, to ignore right here and right here, right? So this is pretty tricky. So if you don't have it, you're going to run out of time, right? TOE, right? So that's it. All right, time and space. So time. This is going to be time. This is going to be time, right? So you're going to traverse every single path, every single stop, right? So it's going to be all of m times m. M represent the number of rods. M represent number of stop, right? So m times m for the time, and this is going to be the same, right? For the worst case, for the best case, it's going to be less than. And then for the space, yeah, you're going to store every single stop into your, queue or hash set. If everything is connected, think about this. 1 to 2, 2 to 3, 3 to 4, and then you come here, and then
and then you keep going 4 to 5, 5 to 6, 6 to 7, and then you come back 5, and then to 8 to 9 to 10, right? And then you want to measure 1 to 10, your source to target, right? So you possibly going to traverse every single one of them, right? So the worst case is still going to be the same, all of n times n. So that's it. All right, see you later. Bye.